think you'll find that when you start looking at the kinetics, things are shockingly different than in the thermodynamics regime. First, I'd like to explore or review the basic gas loading experiment. The reason I want to do this is gas loading is actually quite an elegant experiment. You take a calorimeter, and it can be a hard calorimeter, which is a very precise instrument, or it can be any kind of calorimeter, such as just a RTD on the bottom of a pressure vessel inside a constant temperature controlled oven. All those kind of experiments give you quite accurate data. You take that pressure vessel, you fill it with your test material, and you evacuate it with a turbo pump. We use a turbo backed with a oilless pump to keep oil vapor out of your pressure vessel, but you can even use an oil pump and it will work quite well. You then pressurize it with deuterium and you measure the exothermic reaction, the heat coming out by some means, such as your calorimeter, or a temperature rise on your pressure vessel. Then you evacuate it and you measure the heat going in. And you do it with hydrogen, you measure heat out and heat going in. Now, if there's no chemistry occurring, the heat out and the heat in are equal. That's your internal control. And your external control is the fact that hydrogen and deuterium behave the same. They would behave almost identically if there's chemistry, normal chemistry occurring, but if there's something unusual occurring, such as LENR, they may behave differently. So this elegant experiment, quite simple, quite easily done by almost anybody in the audience, gives you a heck of a lot of information. Now, when we've done this, we've done it a large number of times, thousands of times. And what we see is when we pressurize nanoparticles of palladium